Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on November 10th, 2015. In the last episode, we just finished up our chapter on test fundamentals. We demonstrated how to go through the test-driven development cycle on our tab application. Now, in this episode, we are going to start a new chapter continuing that work. We're going to finish developing our tab library in this chapter. Now, as a reminder, what we have here is a nice suite of automated tests and a nice set of build infrastructure that will make sure that our code lints properly, that is, that it doesn't have any obvious errors, and that it runs on a wide variety of browsers. What we're building here is a little example application that has multiple tabs, so that when you click each tab, you switch between the content. Now, this isn't working yet because we haven't implemented that. Instead, what we have here is 3 content tabs that are all visible. In the last episode, what we had just finished implementing was our first test that just hides one of the elements. Because remember, in test-driven development, we're working in very small steps. So that means that sometimes we'll take a big problem like clicking between tabs and break that down into lots of little problems that we can solve in just a few lines of code. As a reminder, our test-driven development cycle is first think about what we want to do next that we can implement in just a few lines of code. Then red bar, write a small test that will fail until that thing is implemented. Then green bar, write the code to make that pass, and then refactor as much as we can until the code is as good as we know how to make it. In this chapter, we are going to just go through that cycle many times until everything we need for our tab application is complete. Now, what we are not going to do in this chapter is actually hook up our web page. We're just going to implement the JavaScript library that our web page will use. So we're not going to be able to look at how this works until the next chapter when we actually hook it up. But, and this is something that you'll often find useful when you're doing real programs, because we're doing the test-driven development, we should have confidence that the code we are writing works, even though we can't actually see it working. The tests are going to take the place of manually checking the results. Now, it is good to manually check the results as well, but we're going to do that in a bigger cycle than our test-driven development. Test-driven development operates on a very small cycle, and then when I'm doing development, after I get a chunk of work done, I'll confirm that it actually works the way I think it does. Because test-driven development can't ensure that you write good code. It can only ensure that you write code that does what you think it does, which isn't always the right thing. All right, enough recapping. Let's get back to this. So we've got this test that says that our tab library hides an element. What do we want to do with this next? Well, if we look at our to-do, we finished the hide one content div, and the next thing we were going to do is hide one inactive content div. Now remember, what we're on right now is the think step. So we're trying to think of one small thing that we can do that will move our library forward. But over the break, I got to thinking about this, and it occurred to me that the way we are implementing this now is not that great. What we're doing here is we're saying we're creating a test element, we're calling our tab library, and then we're asserting that the tab library has marked the display property for that element as none, has effectively removed it from being displayed. It's the same as taking it out of the DOM. There's a real problem with this, though, and that is that we are tightly coupling our tab code to the way our application or our page is going to look. And this is a somewhat obscure concern, but in general, you want to reduce coupling in your code. Coupling occurs when 2 different parts of your program operate on each other. In order to understand how one thing works, you have to know how something in a completely different part of your program works. So ultimately, once we have this tab page working, in order to understand how the tabs are working, what makes things disappear, we're going to have to jump over to this code to see that it sets the display to none. That means that tabs.js and our page are tightly coupled. And we don't want that. We want them to be loosely coupled. We want to be able to understand the behavior of this page just by looking at the HTML and CSS of the page. We don't want to have to come around and look in tabs.js other than to just know that tabs.js is responsible for the tabs behavior. But by putting this display equals none in here, we're really preventing us from being able to do that. So a less coupled way of doing this would be to have tabs.js set a CSS class on the element so that when we actually set up the tabs library, we can pass in that CSS class and then understand what's going on just by looking at the page and its CSS classes. So for example, our CSS class might set the display property to none. But now we can see that right in our CSS file rather than having to go into the internals of our tabs library. This is a fairly advanced design concept, so if it doesn't make total sense to you right now, don't worry about it. After this series is over, you'll have the chance to go into the live channel where we talk about these sort of design questions in more detail, and you'll have more opportunities to see examples of it in action. For now, just go ahead and trust me that using a class here, rather than setting the display property directly to none, is a better design. Of course, design is subjective, so not everybody would necessarily agree with that, but I really do think it is a better design. It is less coupled. All right, so to do this, what we're going to have to do is change our test. So now let's move on to the red bar part of our test cycle. We know what we want to do. We want to modify this test so that it uses classes rather than setting the display property. Now we need to change the test to make that effect occur. Well, if we look at this, we're creating our div element, we're calling initialize, and then we're asserting that it has the display property. What we could do instead, and then of course we're removing the element. What we could do instead is, instead of saying that we have a specific display property, we could say that we have a specific class, and that we want that class to equal some class value. And here for the test name, we could say sets a class on an element. By the way, one of the reasons this is valuable is that we'll now be able to do more advanced stuff in our CSS if we want to, like using animation to cause the tab to sort of disappear or fade away rather than just vanish. That's the kind of advantage you get out of having decoupled code. You can often get more powerful results from your designs. It's often easier to do fancier things in your designs if the code is decoupled. So we're going to assert that our element has some class on it, and we'll have to pass in to our initialize function that class so it knows what to apply to the element. So let's go ahead and try that. That should fail. Well, it's not failing for the reason I expected it to fail. It's failing because getClass is not defined. So we'll need to implement that to begin with. Let's see. So getClass we can implement. It's going to take the element and it's going to return a class. And what is the DOM code to get a class out of an element? Well, for now, let's just go ahead and return the attribute, the class attribute of our element. And I hope I've remembered the correct DOM method there. Let's go ahead and look that up. So we want to look at getAttribute, element.getAttribute. That looks like it's correct. Let's see, it returns the value of a specified attribute on the element. If it does not exist, the return value will either be null or the empty string. See notes for details. And notes, all browsers return null when the specified attribute does not exist, although some older browsers might return an empty string. Well, I don't think that's something that we're going to worry about too much. So this right here, this should now get the class attribute from our element and return it to our assert.equal. So our test should fail saying that we expected some class but was null. And that's exactly what we're getting. We're saying expected null to equal some class. That's exactly what we expected. Okay, now let's go ahead and make this pass. Rather than saying the display style to none, what we want to do is set the class attribute. And we'll set that to, well, whatever the class name is that we're passed in. and that should pass. All right, now we can refactor. I don't see a lot of opportunities to refactor here. Let's look at our tests. Well, we don't need this anymore. And honestly, we don't need the getDisplayProperty function either. I don't think we're going to use that. So I'm going to take that out. Other than that, I think we are good to go here. So let's go ahead and check that in. So we've modified the tabs.initialize to set a class rather than the display property. Now, there's a problem with this code, which you may not have noticed, but by using setAttribute here, we're overwriting the class. And we don't really want that. We want it to add and remove a class, or eventually we're going to have it remove a class. So here, where we're saying sets a class on an element, I want to say that it does not erase existing classes on an element. So it sets a class on an element without erasing existing classes. So how's this going to work? Well, it's very similar. We're going to say var element equals add element. We're going to initialize it with some class. We're going to assert that the class is equals to some value. But in this case, what we need is we need two classes. So let's come back to that. And then we're going to remove the element. So here, rather than just creating the element, we're also going to need to set the class attribute to have some pre-existing value. So let's call it existing class. And let's call this new class. And we'll expect the result to be existing class space new class, because that's how the class attribute works. Each class is separated by a space. Now this should fail. I think what's going to happen is that it's going to say we expected existing class space new class, but we actually get just new class because our code right now is overriding that class. Let's go ahead and give that a try. Yep, that's exactly what happened. So to fix this, what we need to do is modify the attribute, the class attribute, the way we're doing this code, to append the class name. Now, for those of you who know the DOM, you know that there's another way of working with the class attribute, and we will get to that in a future episode. But for now, let's just keep it simple. So right now we can say existing classes equals element.getAttribute class. And then we can set the attribute to existing classes plus space plus class name. And let's see if that passes. Ooh, it doesn't. We get a null because our first test is failing. Oh, I didn't expect that. What's happening here is when we don't have an existing class, the get class is returning null, and then here, when we say null plus space, it's putting the string null in there. So what we need to do here is say if existing classes equals null, or rather, let's do it this way. Let's say that if the existing classes doesn't equal null, we'll append the new class name to it. And then we can set that value here. So we're saying get the class and then set the class. And in the middle, if it's not null, we'll go ahead and add the class name. That should make this work. I feel like that is not very pretty code, but at this point in the game where we're just trying to get to a green bar, we don't worry about prettiness. We save that for the refactoring step. Don't try to fix your code until it's green. Okay, that still failed. Expected null to equal some class. And that's because I wasn't thinking this through properly. If the existing class is null, we want the new classes to just be the class name. Otherwise, we want to add it to the existing classes. like that. All right, let's give that a try. There we go. That was a rather unpleasant experience, but we got there in the end. Now it's time to refactor. This code, I do not like it. I really don't. There's a lot about it I don't like, but one of the biggest things is just the name of this variable, existing classes. It's sure, when we get the attribute here, it's the existing classes, but then we change it around. So let's just call this classes. I'm going to rename it by finding every use of existing classes and renaming it. And you can use find and replace for this, or in some IDEs, including WebStorm actually, you can use a rename refactoring, which will do the refactoring for you. But I want to show you how to do it manually. So that should still work if I didn't make any typos. And it does. There we go. That's adding our new class name to the list of classes. It's kind of clunky, but I suppose it will do for now. Now here in our tests, I was originally thinking that this first test wasn't necessary, but it actually exposes an important case here. So I want to call that out. It sets a class on an element when that element has no existing classes. And it sets a class on an element when without erasing existing classes. Two different cases. And that brings us through our second test. If you're familiar with the DOM, you probably see some opportunities to improve this code. And that's what we're going to get into next time. We're going to refactor this code to use something called the class list. For now, your exercise for this time is to reproduce what we've done so far. Go ahead and modify the existing code to set a class rather than the existing code. Be sure to handle the two cases of when the class is not yet there and when there is a class already there. And if you're feeling like doing something more advanced, go ahead and take a look at the class list property in the DOM and see if you can refactor this code to use it. That's what we're going to do next time. Thanks for watching, and I will catch you next time.